Even though the universe is absolutely silent, space is actually vibrating all around us. And by listening closely, we can learn some truly terrifying things about our existence. So buckle up, because this is the scariest sound in space. There is no air, so there is no sound. You may have heard this saying before, but it isn't quite true. If this were true, then the universe would be absolutely silent, because it's mostly empty space. But we know that there are lots of sounds out there. The only reason why we can't hear them is because they aren't within the range of human hearing. In order to understand how we can hear sounds from space, we have to first understand how we hear sounds here on Earth. When an object vibrates, it disturbs the particles around it, and those particles collide with ones next to them, and so on, creating a chain reaction that sends waves of pressure through the air. These pressure waves cause our eardrums to vibrate, and our brains interpret these vibrations as sound. So the key to hearing sound is for there to be particles close enough together for the vibrations to be transferred from one to another. So now let's think about space. As we all know, space is mostly a vacuum, meaning that it's almost completely empty. So when something vibrates in space, there's nothing for the vibrations to travel through. Therefore, sound can't travel through space. Or at least it wouldn't. If we could see sound, then we would see that space is full of it. Stars roaring with plasma, galaxies groaning under the strain of gravitational forces, black holes emitting X-rays that could rip our very atoms apart. All of these things are vibrating, but the question is, how can we hear them? Well, scientists have developed a way to decode these vibrations and translate them into sounds that we can hear. This process is called data sonification. In fact, data sonification has been used to convert data from many different sources into sound, such as stock market trends, weather patterns, and even Twitter posts. But we can use this process to listen to all kinds of crazy things from space. In 2017, NASA used data sonification to turn data from the European Space Agency's XMM Newton telescope into sound. The XMM Newton telescope detects X-rays from space, and the data was collected over the course of 30 days from different parts of the sky. Each of the 4 speakers represents a different instrument on the telescope, and each instrument converts different aspects of the X-ray data into sound. The result is an eerie composition that feels both alien and familiar. It's like listening to ghosts from another world. But this isn't the first time that we've explored the terrifying sounds from space. Way back in 2005, scientists converted data from NASA's Cassini probe into sound, so that they could listen to the rings of Saturn. Even though Saturn is 900 million kilometers away from Earth, Cassini was able to detect the small vibrations caused by electromagnetic interactions within the rings. When played through a speaker, these vibrations created an eerie audio experience that made many people feel like they were entering a haunted house. We've also listened to the sound of our own planet before. In 2016, researchers created a sonification of Earth's magnetosphere, the protective bubble of magnetic fields that surrounds our planet. This shield is constantly bombarded by the solar wind, a stream of charged particles that flows from the sun. The resulting vibrations were surprisingly beautiful, like a symphony of the cosmos itself. And finally, we've even heard the sound of solar flares. When sunspots erupt, they send out massive bursts of energy and plasma called solar flares. These flares can last for days and release as much energy as 1 billion nuclear bombs. NASA's Solar Dynamics Observatory captures images of these eruptions, and researchers have converted the data into sound so that we can hear the roar of the sun itself. So now that we've got some background, it's time to explore some of the most terrifying sounds from space. First up, we have to take a journey to the outer reaches of our solar system to listen to the wail of a comet. Comets are icy leftovers from the formation of the solar system that can travel at speeds of up to 400 kilometers per second. As they approach the sun, their ice vaporizes and forms a cloud of gas and dust. This cloud can extend for thousands of kilometers and is pushed away from the comet by the solar wind. When a comet passes close enough to Earth, we can hear the sound of its disintegration. You might be thinking, well, wait a minute, surely we can't actually hear a comet passing by. After all, it's not like we can stick a microphone out in space to capture the sound. Well, that's true, but we can use data sonification to convert the readings from telescopes into sound. For example, in 2014, researchers used data from the European Space Agency's Rosetta spacecraft to create a sonification of Comet 67P. As you'll hear, the sound of a comet is both beautiful and haunting, like the cry of a lost soul wandering the interstellar void. Now let's move on to something a little more terrifying. At the center of most galaxies lies a supermassive black hole, a region of space with gravity so strong that not even light can escape its grasp. Black holes are invisible, but we can observe the effects they have on the matter around them. By studying these effects, researchers have been able to create a model of what a black hole sounds like. To do this, they created a computer simulation of a black hole, and then used a mathematical formula to calculate the gravitational forces at work. The result is a low growl that seems to come from the very depths of hell itself. The sound of a black hole is truly terrifying, just as you would expect from an object that can devour entire stars without batting an eyelid. But that's not the only sound that black holes make. In 2019, researchers used data from the Laser Interferometer Gravitational Wave Observatory to capture the echo of two black holes colliding 5 billion years ago. When two black holes collide, they create ripples in spacetime known as gravitational waves. These waves travel at the speed of light and carry with them an incredible amount of energy. When the gravitational waves reach Earth, they cause a tiny vibration that can be detected by sensitive instruments. It took years for the data to be processed and converted into sound, but the result was worth it. The echo of the collision is both eerie and awe-inspiring, like the sound of a cosmic cataclysm that shook the very foundations of the universe. It's a reminder that black holes are not just fascinating objects of scientific study, but also harbingers of death and destruction on a truly epic scale. Finally, let's return to Saturn and listen to the terrifying sounds from its rings. We already mentioned the eerie audio that Cassini recorded, but there's much more to hear. The rings of Saturn are made up of countless small particles that range in size from pebbles to boulders. These particles are constantly in motion, and their movement creates a variety of sounds. When the particles collide with each other, they produce a high-pitched whine that is similar to the sound of wind blowing through a forest. But there's more to the music of the rings than just that. As the particles move around, they also create magnetic fields that interact with each other. This interaction produces a low rumble that is like the distant thunder of a storm. All of these sounds combine to create an eerie symphony that is both beautiful and terrifying. It's a reminder that even the most familiar objects in the universe can hold many secrets, and that the more we explore space, the more we will discover. Just imagine all the other worlds out there that are waiting to be discovered, each with its own unique sounds and secrets to reveal. Who knows what other terrifying sounds from space we will uncover in the future. Thanks for watching. If you enjoyed this video, please leave a like and comment below with your ideas for topics that we should cover in the future. See you next time.